students. Today I am going to discuss the continuation part of dual nature and matter and radiation. As you know that in the previous class I was explaining about the experimental study of photoelectric effect, and afterwards there we studied about variation of photoelectric current with respect to the variation of intensity of the light, with respect to the emitter and collector plate potential, with respect to the frequency of the incident radiation, and next with respect to the nature of the material of emitter plate. And there we concluded these certain conclusions regarding the experimental verification of this photoelectric current. And as you know that for today's class I am going to discuss the continuation part of this topic. So that is nothing but laws of photoelectric effect. See, listen here. In this topic, under laws of photoelectric effect, see, whatever the experimental verifications or experimental study you have did in case of photoelectric effect, and whatever the graphical conclusions you have drawn there, so the same conclusions only here they made it as laws. They made it a set of conclusions are made as a laws, and these laws we call them as laws of photoelectric effect. So as you recall, the first conclusion we were studied that how photoelectric current is varies with respect to the intensity of the incident radiation. Is it right? So that is the experimental conclusion, that we found that the intensity is directly proportional to the photoelectric current. So as you increase the intensity of the light, the photoelectric current will be go on increases. From graphically we have studied it, and we obtained the conclusion by plotting the graph. So in the same way, here in order to discuss the laws of photoelectric effect, we are collecting all those conclusions what we have drawn from the experimental study of photoelectric effect. So here the first law of photoelectric effect is for a given metal, okay, for a given metal. So metal in the sense what? The material surface. For a given material surface there exists a certain particular frequency, and that particular frequency is known as threshold frequency. Here the first law will tells about the existence of a threshold frequency for the metal. So what is the first law of photoelectric effect here? For a given metal, very important these laws are, because in the examination for 3 marks, very common question that the write the laws of photoelectric effect or explain the laws of photoelectric effect. So which is very important for the examination, as particularly they are asking this for 3 marks. So first law, for a given metal, there exists a certain particular frequency, known as threshold frequency. Underline this threshold frequency. So mainly it's this first law will tell us about the threshold frequency. And the second law of photoelectric effect is for a given metal, and for a given frequency of incident radiation, for a given metal and for given frequency of incident radiation, for a given frequency of incident radiation, the number of photoelectrons emitted per second is directly proportional to intensity of the incident radiation. Intensity of the incident radiation. So I think you got to know that this is the conclusion what we studied while studying the variation of intensity with the photoelectric current. So while studying the variation of photoelectric current with the intensity of the light, there we got this conclusion. So this is the second law of photoelectric effect. So intensity of incident radiation. Okay. So this is about second one. For a given metal, for a given frequency of incident radiation, the number of photoelectrons emitted per second is directly proportional to the intensity of the incident radiation. So third law of photoelectric effect. So like this, you have similarly third law. So that is third law is nothing but the model. See, for a given metal, and above the threshold frequency for a given metal, if a radiation of above threshold frequency, or else if a radiation above threshold frequency in general. So instead of taking this much length, very simple point I would like to tell here. So above threshold frequency of incident radiation, the maximum kinetic energy of the emitted photoelectrons, whatever the maximum kinetic energy which was possessed by the emitted photoelectrons when the frequency of the incident radiation is above the threshold frequency, at the time the kinetic energy of the photoelectron increases, or it varies linearly with the frequency. So photoelectron increases with increasing frequency, and it is independent of increases in frequency. It mainly depends upon frequency. Underline this. But it is independent of intensity. So here I refers intensity. In current electricity it is referred as electric current, but in this topic we refer it as simply intensity, because it is much theoretical concepts. So many theoretical points are there. Each and every point we not supposed to write here. So because just you have to go through the explanation what we are going to explain. Just you concentrate in the class. Either it is of 1 hour or 20 minutes or 30 minutes, it doesn't matter here. So if you have a correct concentration towards this class, you will understand it very easily. See, fourth one. So what is this third law means? Generally, suppose if I incident a radiation above the threshold frequency, then what happens? With the maximum kinetic energy, the electron will eject, but their kinetic energy will be maximum when you cross the frequency above the threshold frequency. What is threshold frequency? Already it is a quite common basic for you people, because threshold frequency is the minimum frequency of the incident radiation for which the photoelectric effect takes place. Okay, so is it clear? So generally, if I take a radiation more than threshold frequency, then the electrons will eject, of course, but their kinetic energy will be maximum. Their kinetic energy will be more, their speed will be more. So, and this is depends upon the what frequency of the radiation, but not on intensity. But it is independent of intensity. So why simply confusion? Better I will write it as intensity only. Okay, next. Next point, that fourth one. So fourth conclusion. See, photoelectric effect is not a time taking process, or it does not takes any much time for the emission of electrons. Practically it is found that the time is very short, that is 10 to the power of minus 9 seconds. 10 to the power of minus 9 second. If you illuminate a radiation of some particular frequency on the surface of a metal, and with the immediately the electrons will get ejected, and what is the time they will take means immediately means it is not the meaning that they do not take any time, but they are taking some time for the emission, but the time is very least. Practically it is a negligible time period here, 10 power minus 9 second. Hence we say that the photoelectric effect is an instantaneous process without any time lag. The electrons are get ejected from the metallic surface. Even the incident radiation is made very dim, though also there will be an emission of electrons will be takes place. This point is very important. Please remember here. So photoelectric effect is an instantaneous process without any time lag. Without any time lag, there will be an emission of electron will be takes place, even though if you made a radiation is of very dim. Okay, so this is about the fourth point. So next, after this laws of photoelectric effect, now we shall go to the study of failure of wave theory of light. Why wave theory do not satisfy, or why photoelectric effect could not be explained by treating light as a wave? Why it can be treated as particle only? So what confirmation you are supposed to giving here in order to give the confirmation regarding the particle nature of light? So for that we require failure of wave theory of light. Why wave theory of light is failed? So failure of wave theory of light. See, listen here students. The phenomenon of photoelectric effect cannot be explained. The phenomenon of photoelectric effect cannot be explained by the wave theory of light. So why it cannot be explained by the wave theory of light means the photoelectric effect confirms that light is not a wave, it is a particle in nature. So what are the conclusions you are supposed to give in order to say like this? So those conclusions we are going to discuss under this topic, that is failure of wave theory of light. Say first point, if light is a wave, suppose if light is a wave, see further point I will tell orally. If light is a wave, then it has to take several days or hours for the emission of electrons from the surface of a material. So what is the first point is, if light is a wave, then it has to take several days or hours for the emission of photoelectrons. But why I have used this word but here? Because we observe that contradiction to this point. What is that? Sorry, not a contradiction, sorry. So just we are observing inverse of this. Is it right? Just opposite for this statement. If light is a wave, then it has to take several days or hours for the emission of photoelectrons. But experimentally, what we are finding experimentally, we are observing that experimentally the photoelectric effect is taking place instantaneously. So instantaneously means without any time lag for the emission of electrons when you incident a radiation. So instantly, so the emission of electrons will be taking place. So this is about the first point. Here it will be to confirm about the photoelectric effect, will treat light as a particle. So second, the conclusion is, if light is a wave, this point is very important. Suppose if light is a wave, then what we have, the maximum kinetic energy of the emitted electrons. See, if light is supposed to be a wave, then electrons will be ejected from the surface of a metal. If you treat light as a wave, then the maximum kinetic energy, of photoelectrons, should increase with increasing intensity. It should increase with increasing intensity here. Suppose if light is a wave, then the maximum kinetic energy of the photoelectron will be increases with increasing intensity, is proportional to what? Intensity. But experimentally what we are observing? We are not observing this condition. We are observing that the maximum kinetic energy of photoelectrons is proportional to frequency. It is proportional to what? Frequency, which is independent of what? Intensity. Is it clear? So this is the condition is there in case of photoelectric effect. So this is another one conclusion about the particle nature of the light. So against to wave theory. So these are the some conclusions. The third conclusion. See, the third conclusion here is, if light is a wave and the sufficient intensity, whatever the intensity of the light is there, that the intensity of the light itself is sufficient for the ejection of electrons. So it means there should not exist any threshold frequency for the material. This is the point. A sufficiently intense beam of light is enough for the emission of electron. There should not exist any kind of threshold frequency or some critical frequency for the material surface. But experimentally, we are not observing this condition. But experimentally, we are observing that there should be a requirement of some particular frequency. Only if that particular frequency is there, then only photoelectric effect will be takes place. It means threshold frequency will be existed. If light is treated as a wave, it cannot be existed. Then now tell me, in photoelectric effect, threshold frequency is existing means definitely which is what? Against to the wave theory of the light. So therefore, it is not explaining the wave nature of the light. So that is the reason, and this is about this, whatever the conclusions we can suppose to give in order to confirm about the particle nature of light here. Okay, students, please concentrate towards this one because it is an online class, it's not an offline class. So that is the reason. So if you concentrate thoroughly to all these points, you can able to answer here and you can able to understand it correctly and you can able to answer for the any questions if it appears in the examination. So therefore, on your part, your correct concentration regarding online class is very important. So okay, fine. After the failure of wave theory of light, so next I am going to discuss about the next topic of this chapter, that is Einstein's photoelectric equation. This is very important. Einstein's photoelectric equation. Einstein's photoelectric equation. This is very important as per the examination is concerned because most of the time for 3 months they have asked about this Einstein's photoelectric equation. See, listen here students. What is this topic will tell us about? See here, actually Howard and Leonard were experimentally studied the this photoelectric effect. So later on they have proved that the light is nothing but the water exhibit particle nature here, and later on wave theory is failed in order to explain photoelectric effect. And later on, like this only, the revolutions have been done. So while explaining this concept of photoelectric effect, but Einstein made here very important thing. At the beginning only, during our introduction class, we have recalled about Einstein's contribution to this phenomenon of electron emission, or to this phenomenon of dual nature of matter and radiation. At the time he said that the matter and radiation has got two natures, and these two natures cannot be separated by any quantities or any different things. We cannot replace these two behavior of the matter and radiation. Once again here also Einstein explaining his photoelectric equation, or he is explaining photoelectric effect by providing its own conclusions or by providing its own ideas. So what are those scientific ideas he is proposing here? So we shall see. See, according to the with the help of Max Planck's quantum theory, in the year 1904, Albert Einstein proposed his explanation regarding the photoelectric effect, and according to Albert Einstein, the photoelectric effect. So according to Albert Einstein, the photoelectric effect is mainly because of whenever the light radiation is emitted or whenever the light radiation is absorbed, generally the emission of radiation, see, emission of light or absorption of a light, whenever the light energy is emitted or it get absorption of light, generally this emission of light and absorption of a light will be taking place in the form of discrete units. This is very important. So it takes place in the form of a discrete units, and these discrete units they call as quanta. So these discrete units they call, generally emission of light or absorption of light will take place in the discrete units, and these discrete units are called as quanta. So these discrete units are called as quanta, and generally later this quanta was named as photon. So this was named as a photon. And listen here, generally and every photon, so there is every discrete unit or every quantum of radiation or photon of radiation is associated with the energy, and that energy is represented with the equation E is equal to h nu. So therefore here E is called energy of the photon, where h is called Planck's constant, where nu is called the frequency of the incident photon or frequency of the incident radiation. So higher the frequency, higher will be the energy associated with the photon. So according to Albert Einstein, if light energy is emitted or if it absorbed by the surface, so in this the emission or absorption will be done, or it takes place in the form of a discrete units. During this process, light, if it is in case of emission, it emitted in the form of a small packets of energy or small, that is a units, and these small units are comprises some particular amount of energy, and these small units or packets of energy are called as quanta, and generally we call it as photon. So each photon has got energy E is equal to h nu. So therefore h is Planck's constant, nu is frequency, and E is the energy associated with the photon. So remember here, so whether the emission or absorption of the light takes place in the form of discrete units known as a quanta or a photon, then energy will be E equal to h nu. This is okay. Suppose if you incident a radiation on any metallic surface in order to study photoelectric effect. So therefore, if your frequency of the radiation or if the frequency of the photon is below the certain particular value, then there is no emission of photoelectrons takes place. There is no emission of photoelectron emission. So then it gives you an idea that there exists a certain particular energy of the photon, and for only that particular energy, and of course that particular energy is the minimum energy only. That particular energy is nothing but what? A minimum energy only. So above that particular frequency only we are achieving the what? A photoelectric effect, and even at that particular frequency also we can achieve it, but it is the minimum condition. So it is the minimum condition, or it is the limiting condition to observe the photoelectric effect. So here, so Albert Einstein observed that the minimum frequency of the photon. So here frequency and Planck's constant, that is nothing but energy only here. So frequency tells about the energy of the light radiation here. Much the frequency, much energetic will be the radiation. So like that. So energy of the radiation is depends upon the frequency here. So listen here. So what happens according to the Albert Einstein, whenever the photon of some particular energy is incidented on the surface of a metal, if there is no emission, so it means that particular material will be required certain minimum energy of a photon. So what we call that minimum energy of a photon? So Einstein named that the minimum energy that would be required in order to eject the electrons from the surface of a metal, or in order to escape the electrons from the surface of a metal, that he called as a work function, and he represented with the letter phi naught. So what is work function? So work function, very important for 1 mark. So what is work function? It is the minimum energy that would be required for the electrons on the surface of a metal for the escaping, in order to escaping from the restraining forces or electrostatic forces with the free electron. So that they require some minimum energy, and that minimum energy we call it as work function. So it is, see, in case of photoelectric effect, Havok and Leonard told you about threshold frequency. In the same way, Albert Einstein was modified it as threshold frequency. Instead of threshold frequency, he said as work function. Both are going to be the same. Suppose if I incident a radiation having the energy greater than the threshold frequency. Suppose if I incident, now I am incidenting a radiation. See why I have written h nu? Because we know that light consisting of small quantum of particles, we call them as a packets of energy, and then the energy of each packet will be equal to h nu. So E is equal to h nu. Suppose if I illuminate such a radiation having the energy h nu, and obviously which is more than work function, then what happens? Then the electrons get ejected, obviously. And remember, what will be the kinetic energy of these electrons? Remember, these not only simply electrons are ejected, they are ejected with the maximum kinetic energy. This is very important. They are ejected with the maximum kinetic energy. Kinetic energy was maximum when the incident radiation is greater than the work function. Then what happens? Then the maximum kinetic energy, the Kmax, the maximum kinetic energy of electrons are getting ejected, and therefore, so Kmax is equal to h nu minus phi naught. So here h nu minus phi naught. Remember here, if they are ejected with maximum kinetic energy, means definitely they are associated with the what? Maximum velocity. If Vmax is the maximum velocity, if Vmax is the, of course Vmax means maximum velocity of the photoelectrons, then this equation can be modified. What is the expression for kinetic energy? Half mv square. So here half mv max square. Why it is max square? Because maximum kinetic energy is equal to h nu minus phi naught. So here this equation is known as a famous equation in case of photoelectric effect, known as Einstein's photoelectric equation. So this equation is called as what? Einstein's photoelectric equation. Very important for 3 months. This equation is important while solving the numericals in case of NEET examination, or in case of JEE, or in case of IIT. For all the competitive examination, as particularly with this dual nature of matter and radiation, some equations. So I think this is the first equation what you got in this topic. So till today only we have theoretical explanation. I told that which is purely a theoretical topic. There is no any much more mathematics here. Only some simple mathematics will be there. Some simple mathematical equations will be there. Among that, this is the first one. So this equation is known as Einstein's photoelectric equation. So therefore, now we shall see, based on this equation, he is giving the explanation for the photoelectric effect. What is the explanation he is supposed to giving? So regarding that we shall study here. Suppose if this is Vmax is equal to h nu minus phi naught. Okay, so what is the Einstein's photoelectric equation? Half m Vmax square is equal to h nu minus phi naught. So from this equation, the first conclusion he is giving, from this equation he is telling that Here, from looking into this equation, the kinetic energy is a non-negative. We did not obtain negative value here. So, its meaning is what? If we are not getting kinetic energy, negative means. So, obviously, the incident energy of radiation will be more than its work function. So, what is this phi naught will be? So, phi naught will be a work function of the material. And generally, so what is this work function can be expressed mathematically means? So, work function phi naught is nothing but it is equal to h nu naught. So here h nu is more than h nu naught. So where nu naught is called threshold frequency. I told now Alvak and Denard they told as what? Threshold frequency. Here he called it as work function by treating it as a photon or a packet of energy. So nu naught is called threshold frequency. Threshold frequency. Once again, threshold frequency. See here, greater the threshold, higher the work function of the material. So it means more energy is required for the material to leave their electrons means. So we require higher threshold frequency. Obviously, threshold frequency will be higher for that material. We require no requirement. So threshold frequency will be more for that material. That understood? Is it clear? So now we shall go second conclusion. Second conclusion, h nu is greater than phi naught. Phi naught is work function, so therefore threshold frequency. Remember here, the second conclusion, the maximum kinetic energy of the emitted photoelectron, maximum kinetic energy of the emitted photoelectrons is directly proportional or it increases, means kinetic energy of the emitted photoelectron is increases with increase in frequency. It linearly increases with increase in frequency. Generally I will write it is proportional to frequency of the incident radiation, but it is independent of intensity. But it is independent of frequency, intensity. So this is the second point. The third conclusion about, or the third point to explain this photoelectric effect, what he is explaining means this phenomenon of photoelectric effect is arises due to the collision between a photon as well as the electron. So what he is telling means, he told that energy will be emitted, light energy is emitted and or it is absorbed in the form of a small packets of energy called as a photon. But generally what happens, how this photon is actually absorbed or how it gives its energy means, regarding that the third point we say it is a metal surface. It consisting so many free electrons, we call them as a valency electron. When you incident some particular frequency of a photon having energy is equal to h nu, then what happens means this photon will collide with this electron. Actually collision will be taking place here, and due to this collision what happens, the energy of the photon is completely transferred to the electron. Now this electron will become sufficient with its energy, and now it get free to come out from the surface of a metal. So during this, what he is explaining means in this condition, if I want to look the more number of electrons in a 1 second to come out, so what is that we call as rate of emission. So this rate of emission is depends upon what? So here Newton explaining that the rate of emission of photoelectrons is mainly depends upon the number of photons per second. Say number of photons per second is mainly tells about the water intensity. Indirectly we say that the number of photons per unit area per unit second is directly proportional to the intensity of the incident radiation. So if the rate of emission of electron will be more, so more and more number of photons per unit area per unit second should incident on the surface of the metal. Thereby each electron will absorb the sufficient energy of all the photons in a same time, and thereby the maximum number of electrons get ejected. So therefore purely this photoelectric effect is nothing but the what? It is a collision between a photon and a single electron. If more number of photons per unit area per unit seconds are available means it understood that light is of high intensity. So higher the intensity, so more rate of emission of electron will be there. So indirectly the photoelectric current will be high. So the third point is nothing but what? So greater the rate of emission of photoelectrons from the surface of a metal is directly proportional to the intensity of the incident radiation, which is independent of frequency. And the next one is fourth point. So what is that fourth point means? The photoelectric effect is mainly because of collision between a photon and electron. It is a collision between the what? Photon, incident photon as well as electron. The collision between this incident photon and electron, during the collision, this electron will completely absorb the energy of a photon, thereby it get ejected. Remember, to absorb the energy and to get out from the surface of a metal, it do not takes any 1 hour or 2 hour. So very instantaneous process it occurs. So therefore, what Einstein is observed in this, in his explanation, before explaining this photoelectric effect means, before concluding this photoelectric effect, he observed that the absorption of energy by the electron from the incident photon is, it do not takes any much time. Without a time gap, this process will be taking place. So hence he concluded that photoelectric effect is an instantaneous process. So this word is very important, instantaneous. Without any time lag, the emission of electron will be taking place. Are you getting, students, here? So this is about the explanation of Einstein's photoelectric equation. Suppose, see, we know that if VO is the stopping potential, what is stopping potential? A minimum negative potential given to the collector plate for which the what emission of for which the photoelectric current will becomes 0. So we know that at stopping potential VO, what happens when you give a stopping potential? Stopping potential is nothing but the what? A minimum negative potential plate given to the collector plate. At that time, all the photoelectrons get repelled from the collector plate. It means this potential will be converted as a work done on the electron in order to repel from the collector plate. So therefore, if VO is the stopping potential, then we know that the maximum kinetic energy will be ejected electron is given by K max is equal to EV naught. Yes or no? So we obtained this condition during the study of variation of potential with the photoelectric current. So under that, we have concluded while studying the variation of potential with the water collector plate potential on a photoelectric current. So the K max equal to EV naught, and therefore, so this equation I can also modify as half mv max square is equal to h nu. What is phi naught? H nu naught. Therefore, half mv max square is equal to h is common, nu minus nu naught. So here from this equation we can clearly tell that the maximum kinetic energy of the photoelectron is directly proportional to the frequency. So this is another one form. So now I can express K max is equal to EV naught. Therefore, what is this equation 1 becomes? Equation 1 becomes K max is equal to what is K max is equal to EV naught. So in place of that K max, I will write it as what? EV naught is equal to h nu minus phi naught. So from this equation, V naught is equal to h by E into nu minus phi naught by E. See, phi naught by E, h by E, V naught is equal to, this equation is similar to what? Equation of a straight line, mx plus C. So therefore, so from this equation what we are confirming here, the stopping potential is purely dependent on what? Frequency. Yes or no? Stopping potential is independent of intensity. It depends upon the frequency of the incident radiation. So therefore, this is another one form of expressing Einstein's photoelectric equation in order to confirm experimentally. So how this Einstein's theory is true or not. So experimental confirmation we can also get know here just with the help of his equation. So his equation is purely what? So with the degree of experimental study of photoelectric effect. See, V naught is proportional to nu, where h by E is constant, phi naught by E is constant. So therefore this is an equation of a straight line. So from this we can say that threshold frequency varies, not threshold frequency, the stopping potential varies linearly with the frequency. Stopping potential varies linearly with the frequency. So this is about the thing. So next, in our next lecture, I would like to explain particle nature of the light. So how you can confirm about particle nature of the light, and what are the suppose if you say light as a particle, so already we are getting confirmation from all these observations, and while studying the laws of photoelectric effect and failure of theory of light, and even from Einstein's photoelectric equation. So once again in my next class, I will explain about the particle nature of light. So how this, already Einstein told that the light consisting of some small packets of energy, so that's called as quantum, and his theory was purely based on Max Planck's hypothesis, Max Planck's quantum theory. So now he treated as a particle. In what way he treated as particle? Whether this particle nature later it was confirmed or not. So it was confirmed by A.H. Compton. In the year 1924, the A.H. Compton was confirmed. The Compton's effect we call it as, after the photoelectric effect, Compton effect. In the introduction only I told these two phenomena are dealt with particle nature of light. That Compton's effect will prove that the particle nature of the light. Then what is this name? What is this photon? And what is the characteristic of this photon? Okay, so regarding that I am going to explain in my next lecture.